Hi guys, welcome back from spring break. Today we're going to be reviewing everything you learned in the previous weeks before spring break. I know you've slept since then and forgot everything that I told you. Make sure your cell phones and headphones are put away. Make sure you've got your notes out and you're ready to go. My expectation is you are taking notes. First thing I want to address is that this is the homework assignment that is due. It's your ocean worksheet. If you didn't get it done, it is uploaded on the web page. You can print it and get it done, but that is what is due today. Make sure when it's appropriate that you get that in the basket. I'll be grading it when I return. Let's start with evaluating rational exponents. So when we have rational exponents, in this case a 1/5, I taught you guys last week how to translate these into roots. Now, if you remember, this number, the 3,125 in this case, becomes your radicand. So the big number, the base, becomes the 3,125, becomes the radicand. The denominator becomes the index. So I know that I'm taking the fifth root. And if you guys remember, there's two places we can put this one. We can put it on the inside or we can put it on the outside. I know a lot of you put it on the outside. In this case, I'm going to put it on the inside. 3,125 to the first power is in fact 3,125. And if I go into my calculator and do the fifth root of 3,125, you should get a 5, and that is your answer. All right, for this example, we're going to be graphing a radical. So what we want to do is we want to look for our shifts. This is our left shift. However, when we rip it out of the radical, it changes sign. So for that shift, we're actually going to go to the right 3. For this shift right here, we're going to go down 1. We're not pulling it out of a radical, so we don't change the sign. So the beginning of my graph, instead of starting at 0, 0, I'm going to start right 3 and down 1. So that is going to be my vertex in the graph of my square root. Now for domain and range, for domain, we went 3 to the right, 3 to the left, and to the right to infinity. For my range, I went down 1 and up to infinity. All right, let's look at something that you will see on your test that can cause a little bit of confusion. What we're doing here is we're multiplying two numbers with exponents. We've got 4 to the 1/3 times 4 to the 5/3. 4 to the 1/3 times 4 to the 5/3. Now when we multiply two like bases, what we do is we carry over that base. So we're going to carry over that 4 as a base. We're not going to multiply. Don't write 16. We're not going to multiply. We're going to carry over the 4. And what we do to the exponents is, in fact, we add them. 5/3 plus 1/3. They have a common denominator of 3. That's going to give me 6/3. 4 to the 6/3 is 4 squared, or 16. So what I want you guys to remember here is that when you have like bases, all you're going to do is add those exponents. When we have like bases, all we're going to do is add those exponents. For example number 3, what we're doing is we're multiplying two radicals. Now, when we talked about multiplying in class a few weeks ago, we talked about how the only way we can multiply radicals is if the indexes are the same. Both of these are a cube root, so I'm okay to go ahead and multiply. Now, just like I talked about in the last slide, these bases that we're about ready to multiply, these bases are the same. They're both a y. So remember, when we multiply like bases, we're going to add those exponents. Now, since these are both a cube root to begin with, our answer is also going to be a cube root. So what I end up with is y to the 7th plus y squared is the cube root of y to the 9. Now, we always need to reduce. So if I have 9 y's, I'm looking for groups of 3. I've got a group of 3 here. I've got a group of 3 here. And check it out, guys. We've got a group of 3 here. It looks like we have 3 groups of y's that get to come out. Now, since everything is circled, nothing goes back in the radical. Our answer is just y cubed. There's no radical left. Much like the last problem, what we're going to be doing is we're going to be reducing this. So we're not multiplying here, we're not adding or subtracting, we're just simplifying. If you would plug something like this in the calculator, you would not get a nice clean answer because we need to reduce this by hand. So we're going to start with the 125. Can't divide it by 2, can't divide it by 3, but I can divide it by 5. When I reduce 125, what I end up with is 5 times 5 times 5. I'm looking for groups of 2 since this is a square root, and it looks like I have a group of 2 right there. Don't forget your x to the 5 and your y. Here's my x to the 5, here's my y. I am still looking for groups of 2. Now remember, anything circled gets to come out, anything not circled has to go back in. So this 5 gets to come out, the x gets to come out, and this x gets to come out. Anything not circled has to go back in the square root. This 5 is not circled right here. Well, now it is. This y is not circled and this x is not circled. So that 5xy are going to have to go back in the radical. This is your reduced, simplified answer. In this case, we're going back to multiplying. We're multiplying root 5 times the cube root of 2. The first thing I notice is they don't have common indexes. The index to this 5 is a square root. And in fact, I can go ahead and write a 2 there. The index here is a 2. The index here is a 3. These do not have common indexes. And because they don't, we cannot multiply them straight away. If you guys remember from a couple weeks ago, what we're going to have to do is do a little bit of conversion. So the first thing I'm going to do is I'm going to take the square root of 5, and I'm actually going to convert it to 5 to the 1/2. And I'm going to take the cube root of 2, and I'm actually going to convert it to 2 to the 1/3. Now when I get here, keep in mind, I still can't multiply. Why? Because those bases are not alike. Remember, in the last few problems we had like bases, so we just had to add the exponents. These are not like bases. So the next thing that we're going to want to do is get a common denominator. Well, between a 2 and a 3, it's a 6. So once I get that common denominator, I end up with 3/6 and 2/6. Once again, I repeat, we still can't multiply. These bases are not alike. My only choice then is to go ahead and convert them back. So I get the 6th root of 5 cubed times the 6th root of 2 squared. At this point, I'm going to take my 5/3 and my 2 squared. 5 to the 3rd is 125. 2 squared is 4. 125 times 4 happens to be 500. So the 6th root of 500 is my final solution. That is how you multiply when they do not have like indexes. We are nearing the end. We've got 3 or 4 problems left. Hang tight. I know you guys are getting antsy and tired. Put your cell phones away. I know a few of you probably have them out. Make sure you're taking notes and paying attention. Remember, I have eyes in the back of my head even when I'm not at school. In this case, we are subtracting. If you see this minus sign right there in the middle that I just made blue, we are subtracting. Now, let's talk about the rules for adding and subtracting. The rules for adding and subtracting are this. Not only do they have to have a like index, but the radicand, or the number underneath the root, has to be exactly the same on both of them. So a lot of times what we end up having to do is reducing our radicands so that we can go ahead and subtract. Now, I'm going to look at this first radical. I'm looking for groups of 3 because my index is 3. Out of 1x, I'm not going to get a group of 3. Out of 2 y's, I'm not going to get a group of 3. Since I know that that cannot be multiplied. So I know 3x cube root xy squared cannot be reduced. Now I'm going to come over here and try to reduce this guy right here. So I'm going to start with my 8. So I've got 8, 2, 4, 2, 2. I've got 2, 2, 2. I've got 4 x's, and I have 2 y's. Now remember, we're looking for groups of 3 because that index right here. So I've got a group of 3 2's. I've certainly got a group of 3 x's. I don't have a group of 3 y's. So this 2 gets to come out. Now remember, this 2 gets to come out with the 2 that's already there. We're going to multiply them. 2 times 2 is 4. I also get to take this x out. So this x is going to come out right there. Now anything not circled has to go back in. So it looks like one of my x's is going back in and both of those y's are going back in. So xy squared is going back in. Now we need to reevaluate what we have. They both have to have the same index to add and subtract. We got that. They have to have the same radicand to add and subtract. We got that. What we do here is we take the numbers that are on the outside, in this case 3x and 4x, and we subtract them like we would in Algebra 1. 3x take away 4x's is negative 1x's. Our radicands that we have forced to be alike, they just come straight down, almost like a common denominator. They don't really do much. That's how you subtract. So that is our final answer. All right, let's take a look at this problem. In this case, we're multiplying. How do I know we're multiplying? If you look in between these parentheses, there's nothing here. There's no plus, there's no minus, so we know we're multiplying. I also know that I've got two quantities. I've got two expressions. They're holding hands with this plus sign. They're playing Red Rover. They're holding hands with this minus sign. They're also playing Red Rover. So when we multiply two expressions, if you remember from before spring break, we're going to have to multiply it out the long way and really take our time. Now on these, my advice to you is to go really slow, go piece by piece. It's easy to make a mistake. 2 root 3 times 3 root 3. We're going to take outside times outside, inside times inside. So the outside, 2 times 3, 6. The inside, root 3 times root 3, root 9. I'm going to go to my second step. 2 root 3 times a negative 2 root 5. So it's going to be negative. And I'm going to take outside times outside, so 2 times 2 is 4. Inside times inside, root 3 times root 5 is root 15. Now I'm going to go to my root 5. I'm going to start over. So root 5 times 3 root 3. I know it's going to be positive because it's positive times positive. Outside times outside, inside times inside. Well, the only outside number I'm given is the 3. Inside times inside, 5 times 3 is root 15. Last but not least, root 5 times negative 2 root 5. It's going to be negative. Outside times outside, is 2. Root 5 times root 5 is root 25. Now, we're not done. This is going to get a little tricky because we've got to do a little bit of cleanup here, guys. I know the square root of 9. Square root of 9 is 3. So instead of 6 times the square root of 9, it's 6 times 3. I know the square root of 25. The square root of 25 is 5. So instead of 2 times root 25, I actually have 2 times 5. So what I actually have for my numbers is I've got an 18 and a negative 10. So I've got 6 times 3 is 18. I've got negative 2 times 5 is negative 10. Now let's look at our middle guys. These both, not only are they both square roots, so they have the same index, but they both have identical radicands, which means it's okay to go ahead and add them. I can put them together because they're both a square root of 15. So what we do is we add the outside, so negative 4 plus 3 is negative 1, and then we carry the root 15. Now I'm not quite done because what I notice is this 18 right here and this negative 10 can go together. So 18 minus 10 happens to be a positive 8. I'm going to carry down that negative 1 root 15, and that is going to be our final simplified answer. All right, here we've got a quantity squared. How do I know it's a quantity squared? Well, I've got a minus sign. They're playing Red Rover. That's a quantity. And so the whole thing is squared, not just one piece or the other. When this happens, as you know from our last few problems, when we square a quantity, you have to write it twice and then multiply it out the long way. I'm going to ask you guys now to pause the video. And I want you, on your own, give yourself 2 minutes, I want you to multiply this out. And then you come back to me, and I'll go through the final answer with you. All right, hopefully you've been given 2 minutes. Hopefully you've got the correct answer. Here we go. Root 11 times root 11 is the square root of 121. Root 11 times negative 1 is negative root 11. Negative 1 times root 11 is negative root 11. Negative 1 times positive 1 is positive 1. I know that the square root of 121 is actually an 11. So I'm going to take this 11 plus 1 and I'm going to get a 12. This 11 right here plus 1, I'm going to get a 12. I also notice that the radicands here are the same. They're both the square root of 11. So I can put them together. Negative 1, take away one more, is negative 2 root 11. That is what you should have gotten for your final answer. All right, let's talk about division. We all know there's certain things as upper level math students that bother us, and one of those is when we leave a radical in the bottom of a fraction. I see a radical in the bottom of this fraction. It's radical 24. I don't like it. We need to get rid of it. If you remember correctly, that is called rationalizing the denominator. Now, step 1 when we rationalize is to reduce what we're given. I've been given the root 24. I'm going to reduce that. Root 24, looking for groups of 2, actually will reduce to root 6. Now, the radical that's causing me the trouble is the root 6. And if you remember correctly, we multiply by the radical that's given us grief. Top times top, negative 5 times root 6 is negative 5 root 6. Denominator times denominator, 2 root 6 times root 6 is root 36. Now we're still left with the radical in the bottom, but what's neat is we know the square root of 36. Square root of 36 is 6. So as I go to write this answer, I know that I don't have 2 times root 36. I actually have 2 times 6, which is 12. Our final 2 steps are to check to make sure our radical can't be reduced. I can't reduce the square root of 6, neither can you. And then to check your fraction. Can I reduce the 5 and the 12? I can't. Once you know that both of those things are simplified, you're done. And that's your answer without a radical in the bottom. All right, guys, last one. You made it far, and I'm really proud of you. Let's check this out. I see a root in the bottom, but not only do I see a root, I see a quantity of a root, an expression. They're held together by this minus sign. They're playing Red Rover. When we need to get rid of a quantity in the bottom, we multiply by something called the conjugate. So in this case, the conjugate of root 6 minus root 5 is root 6 plus root 5. So what we're going to do is we're going to multiply top and bottom by the conjugate, which is root 6 plus root 5. Now what's going to happen in the numerator is we're going to end up having to take that negative 1 times both pieces. Negative 1 times root 6 is negative root 6. Negative 1 times root 5 is negative root 5. In the denominator, it's going to be a little bit more of a mess. We're going to end up with root 6 times root 6, which is root 36. Root 6 times root 5, root 30. Negative root 5 times root 6, negative root 30. Negative root 5 times positive root 5, negative root 25. Now let's clean this up. First of all, positive root 30 and negative root 30, they're going to cancel. I'm going to be left with root 36 minus root 25. Now I know square root of 36 is 6. I know square root of 25 is 5. Well, I know 6 minus 5 too. It's 1. So I'm left with negative root 6 minus root 5 over 1.